Abhishek. Sir has completed his post graduation in geology from Mysore University. He is working with us SVC past 2 years, and he has a vast experience with the aquifers present throughout the India. Now, I request the today's keynote speaker, Mr. Abhishek Yes, to kindly address the audience on a topic uranium occurrence in shallow aquifers of Karnataka. Over to you, sir. Abhishek.
Thank you, sir. Thank you. So first of all, I would thank to Chief Patron Shashidhar sir and Principal Sir Nageshwar Gupta and the IIC convener Nirmala Gupta, and I personally thank our department head Lata Madam and the IACC coordinators Chandrasekhar sir, Anil sir, Tyagras sir. So myself, Abhishek, has working as an assistant professor in civil department, SVC Bengaluru. So today topic is I am going to give some input about the uranium contamination, especially in the groundwater, which will impact on the human life and the soil and various environmental factors that I will going to point out today. So we all are aware about the water pollution, especially due to various factors like natural process or due to by anthropogenic process and various chemicals like fluoride and radon. In addition to that, uranium also contaminate and it will pollute the water at severe level, and it will also causes lot of it will also leads for various health damages that we will going to see now. And today's topic is about uranium occurrence in shallow aquifers in Karnataka. Okay, especially Karnataka. We are from Karnataka, so I just take this a part from the Karnataka only. And as we know, India totally the India it is a major country which is depending upon the groundwater. Okay, we have a lot of demand in various sectors like agriculture, like industries, like in domestic purpose, drinking purpose, and urban needs. We totally depending upon groundwater. Why? Because in throughout India we don't have rivers. Okay, in some terrains we have dry areas. In that terrains we have to go through with the groundwater only. So in that groundwater, recent studies that will reward there is a presence of the uranium in higher levels in that groundwaters in some few areas in few states also. So uranium, basically you know that uranium is a radioactive element which is present in which is present in some rocks and soil and even in air and even in plants and even in our body also in varying amount. Okay, and this uranium which is having three isotopes, that is uranium 234 and uranium 235 and uranium 238. Okay, and this is these isotopes have a different radioactive property, but it will these three isotopes chemically behaves the same. Okay, and the isotopes have their different valence electrons, that is +2, +3, +4, and +5. Naturally, most of the cases hexavalent uranium is available most in our nature. Okay, and it is highly reactive also. It will react with oxygen very quickly and other chemicals also compared to other valence uranium components. Okay, and let us know about some drinking water standards that is given by the various boards throughout the world that we see now. WHO, okay, World Health Organization, it set a standard for the uranium concentration in the drinking water, that is of 30 40 microgram per liter. Okay, and also one more board, that is Atomic Energy Regulatory Board from India, that is also set a maximum limit of uranium concentration in drinking water of amount 60 microgram per liter. Okay, but however, the Bureau of Indian Standards, it is not set a specified norms for the uranium levels in the drinking water right now. So before going to start the uranium effects and its causes, source, and this distribution throughout India and also in Karnataka, let us understand some points, some hydrological units of our India. So the groundwater system and its behavior, it is totally different from one area to another. Okay, that is totally depending upon diversified geological formation and lithological variation, rock variation, and also some climatical dissimilarities and various geomorphological factors and hydrochemical conditions, that it will going to vary the hydrological behavior from one region to another region. Okay, and this rock formation we broadly classified into two formation, that one is porous formation and fissured formations. So porous, again in this porous formation, we further classified into two groups, that is unconsolidated and semi-consolidated formations. Okay, the areas which is covered by alluvial sediments of river basins and coastals and deltaic tracts constitutes this kind of the unconsolidated formations. Okay, and these are the most significant groundwater reservoirs for large scale and also extensive development also. Okay, and also the hydrological and also the hydrological environment and also groundwater regime in the Indo-Ganga Brahmaputra basin indicates the extensive in the potential aquifer having enormous fresh water. Okay, and come to the this semi-consolidated formation, that is covered up in Gondwanas and Latis and Tipams and Kadalur sandstone. There is also have some extensive potential groundwater resources. They also act as a significant groundwater reservoirs. Okay, and come to the one more formation, that is what the fissured formation. Basically this kind of rocks, they don't have at primer condition, they don't have any kind of pore spaces in their formation. Okay, after due to some changes on the earth surface, inside the earth surface, they're going to give some fissures. Okay, they're going to develop itself there some cracks and wide spaces in their formations. Okay, that rocks like igneous rocks and metamorphic rocks and volcanic rocks and the consolidated sedimentary rocks and carbonate rocks. Okay, and come to these igneous rocks. Okay, the well-known igneous rocks such as granites, gneiss, charnockite, condalites, and quartzites, schist, and associated fillets and slates. These kinds of rocks, they possess a negligible primary porosity, but they attain porosity and permeability due to further fracturing and weathering and development of cracks in the body itself. Okay, and come to the volcanic rocks. Okay, these are the predominant rock types, okay, which is formed by the cooling of the lava. Okay, basically we can see this kind of rocks in regions of Maharashtra and northern part of the Karnataka also. Okay, like the Belagavi and all. Okay, and also one more rock is there, rhyolite. These are what the volcanic rocks, and they have basically some cavities or some pore spaces on their formation, on the surface of their formation, and these are also attain some fractures and some other structural features due to some changes in the body by applying some forces by due to some tectonic movements inside the earth, and also some consolidated sedimentary rocks which occur in Kadapa and Vindhyans and their equivalents. Okay, and these rocks consist of like conglomerates, sandstones, and the shales, seals. Okay, the presence of structural features like bedding planes, joints, and contact zones. Okay, so that it will influence the storage of groundwater in this kind of formations. And one more rock formation is also there in our Indian terrain, that is the carbonate rocks, that is limestone. Okay, that is appeared in Kadapa and Vindhyan and Vijayawar group of rocks. Okay, and this limestone, which is totally dominated with the chemical called calcium carbonate. Okay, so basically this rock is also lack of porosity in their formation due to the increasing in the solubility of the water with this particular carbonate rock like limestone. It will create the cavities, thereby increasing the permeability of the aquifer. Okay, and it will also create itself, it create itself the porous and cavities to circulate the water through their origin. Okay, this is about some hydrological units and rock features of our India. So come to the point of the source of uranium. So it is a heaviest natural mineral which is dispersed in state in the earth crust. Okay, and which is average concentration of 2 to 4 milligram per kilometer, and it is commonly present in some minerals like niglite, lignite, and monazite and phosphate rocks, and typically of average 0.0052 to 0.02%. Okay, and in groundwater, the uranium present due to the leaching from natural deposits and also releasing of uranium from the mill tilings and also emission from nuclear industries and also contribution from fly ash and the uses of the chemical fertilizers like phosphate fertilizers and nitrate fertilizers. Okay, these all leads for the source of uranium, especially to the groundwater. Okay, and this uranium, naturally occurring uranium in the groundwater result by the dissolution of this particular uranium bearing mineral with the water through up to long period of time. That will leads for the presence of uranium in the groundwater. And this uranium concentration, it is basically high in the drilled wells compared to the dug wells. Okay, and also the surface water supplies also. Okay, and also this uranium concern, particularly this topic is about low concern about the radioactive properties. It is highly concerned about the chemical properties of the uranium in drinking water. I already told this source of uranium is also from the usage of the phosphate fertilizers also. Okay, this phosphate fertilizers which is having the uranium concentration of 9 into very high level. So if you use this kind of fertilizers for our agriculture purpose, it will easily make a contact with the surface water and it will penetrate and it infiltrate, and finally it will totally contaminate the groundwater as well. So we have to avoid that one also. And even the usage of the other chemical fertilizers like the nitrate fertilizers also, and some factors let we understand that will give the concentration of uranium in the groundwater. And basically the aquifers that is composed with some geological formations such as clay, silt, and gravel. These are carried down from the Himalayan region. Okay, due to some weathering, due to some physical activities, they carried from the Himalayan regions through the streams. Okay, and by the uranium rich granites and pegmatites. Okay, thereby the water can easily mix up with that uranium and leads for the contamination of uranium in that water. And also the possibility, one more possibility is source for the uranium is the decline of water level in the wells. Okay, if it declines, it will leads for the oxidation. Means basically the uranium it will not directly mix with that water. Okay, they don't have that much of capacity to directly mix with that water. It will change their composition by mixing with the oxygen. Means it will oxidize first. Means by the oxidation of the uranium, it will going to form as a uranyl ion. Thereby it can easily soluble in that water. So that is how the uranium going to mix up with that groundwater. Okay, so the decline of the groundwater is also one more point here for the source of groundwater. And also some usage of, as I told, the usage of the the chemical fertilizers like nitrate fertilizers and the uh, phosphate fertilizers also, and also the water rock interaction. Okay, that is also leads for the leaching and extraction of uranium from the sediments and from the rocks also. Okay, and also the interaction of the water with the carbonate or sulfate rich rocks, that will also makes the uranium contamination with that water. Okay, so one thing you keep in your mind, uranium, it is not directly mixed with that water. Okay, it doesn't dissolve with that water directly. First it should act oxidize first. Okay, by making a contact with other chemicals that is present in that water, like carbonates, bicarbonates and sulfates. Okay, thereby it can react with the water. Okay, that is how it will going to pollute the water. Okay, so that point to keep in your mind. So some more anthropogenic activities like over exploitation of groundwater, it leads for the decline of the water level. Okay, that leads again the oxidation, and also the uranium is more soluble in oxidizing or in alkaline waters and carbon rich waters. Okay, and let's we see some health effects. Okay, if we consume the the water or food which is contaminated with the uranium, what will happen, that we will see now. Basically, if we consume uranium either through water, either through the food, it will not affect our body. Okay, basically it will not affect our body if it is in lower levels. Okay, if it is in higher levels, it will affect our body in various ways. And this low level concentration of uranium in our body, it will eliminate through the urine or feces like process. And if it reach the higher level concentration in our body, it will cause us the nephritis, like the kidney damage, or we say failure of kidney. And also it will also cause us deformity of bones and liver also. And also it can cause the thyroid cancer and blood cancer and depression and other serious elements it will cause. Okay, these are some health effects that is by the uranium that will consumed by ourselves. And next come to the point, that is the uranium distribution throughout India. Okay, especially in the groundwater. This is the image that I picked from the a report that is published by the groundwater Central Groundwater Board, Uranium Report 2020. Okay, wherever you see that the pink spots, they are the wells that is totally contaminated with the uranium. Okay, that wells that is totally contaminated with the uranium. Okay, it is totally high in the northern part of India and also southern part of India, especially Karnataka and some parts of Andhra Pradesh, some parts of Tamil Nadu, and even some parts of Kerala also. Okay, so the Central Groundwater Board, it was collected around 14,000 of groundwater samples from various parts of India. Okay, these samples, it will shows various concentration in uranium, that is from 0.02 2876 microgram per liter. This is the variation we see in these samples throughout the India that is collected from the wells. And let us see some of the affected states that will already exceeds the WHO prescribed limit, that is 30 microgram per liter. That states are the Punjab and Haryana, Telangana, and also Rajasthan, Andhra Pradesh, and Uttar Pradesh, and also some parts of Karnataka, Madhya Pradesh, Tamil Nadu, Jharkhand, Chhattisgarh, and some more states. Here you see the table of content here. These are the samples that is collected throughout the India in some few states. Especially, I just go with the Karnataka, around Karnataka and Goa combined form, around the 804 samples that were collected. Okay, out of that 804 samples, 15 samples that will shows, that will gives the values of about 300 ppm, ppm, and also one more sample that is also crossed the limit of 60 microgram per liter also. Okay, and the concentration of uranium observed maximum is 201.1. Okay, this is the concentration level, the maximum concentration level that is observed in, especially in Karnataka. So here the district wise affected areas. Let us see the Karnataka, the Bangalore rural and Bangalore urban, Ballari, and some parts of Gulbarga and Kolar and Mandya, Raichur and Tumkur. These are the states, and even Chikbalapur also. These are the some few districts, especially in Karnataka, that is affected by the uranium contamination in the groundwater in our state itself. So this is the status of uranium in groundwater in different states and UTs also. Just see the bar graph of Karnataka and Goa, around more than 500 samples that were collected, and out of 500 samples they show around more than 15 samples shows more than 30 microgram per liter of uranium, and more than one sample shows 60 microgram per liter of uranium. Now let us see especially the Karnataka part. And around in Karnataka they collected around 737 water sample by the CGWB. Out of 737 wells, 14 wells exceeds WHO permissible limit of 30 microgram per liter. Okay, which is especially the districts like Gulbarga, Mandya, and Raichur, Bangalore urban and Bangalore rural, and Tumkur, Ballari, and Kolar. These districts exceeds the permissible limit of 30 microgram per liter. Okay, and also the highest value of 201.01 microgram per liter was recorded at the location of Chintamani. Okay, and Tesli of Kolar district. And some villages in Karnataka like Tumkur, the villages in Tumkur and Chitradurga district, and 5 villages in Kolar and 7 villages in Chikballapur, that is also contaminated with 1000 micrograms per liter of uranium in their wells itself. That is show given by the published by the study Current Science. And also the study was conducted by the scientist from the Devicha Center of Climate Change, Indian Institute of Science, and Center for Advanced Research in uh, Environmental Radioactive and Mangalore University are uranium concentration in groundwater used for drinking purpose in 73 villages, especially in Karnataka. Okay, they made a repeating sample was done in 4 localities of Chikballapur and Kolar district. Okay, they collected these samples in the time of February and July. Okay, whatever the samples that is collected in the time of February shown higher content of uranium. Okay, and the collected samples at the time of July, it will show lower content of uranium. Here we can understand in the January and February time, there is a declination in the groundwater level. Okay, at that time the oxidation process inside the ground is more, so that will leads for the uranium contamination in the groundwater. And come to the time of the July, it is a rainy season, so that time the groundwater tends to move up. Okay, the groundwater level, it will going to be comes up. That time the oxidation process, it will going to be decreases. So the possibility of uranium contamination in that groundwater in this time is basically low. So that was done by these institutes, reputed institutes. And this especially the uranium is highly rich in granitites and granitic rocks, and also some gneissic rocks also. So here you see the table. Okay, especially Bengaluru rural Devanalli, the site is the located site is Podurki, around 39.47 microgram per liter. This much of uranium noted in this particular site. And also in the same place, Avati, 111.84 microgram per liter of uranium is noted. And also Bangalore urban, that is Gollalli. In that, you have to see 104.2 microgram per liter of uranium is noted. And some more parts of the Karnataka you can see, and even in that third column you can also see the spots where they collected the samples. Okay, and even the Chintamani, here you see the Chintamani in Kolar. Okay, it gives the more concentration of uranium of about 201.01 microgram per liter. Okay, this is the highest uranium concentration in Karnataka. Okay, here you see the map. This particular pink spots shows the uranium concentration in higher levels more than 30 microgram per liter. And let us see some of the remedial measures how we can eliminate this uranium from the groundwater. We can easily eliminate this uranium from the adsorption or ion exchange method by adding some activated aluminum or activated carbon in that water, that contaminated water with the uranium. It will eliminate, or it will attract that uranium and some other chemicals like fluoride and radon, like that. And also we can eliminate this uranium from reactive sorption and precipitation, means addition of alkalis to rise the pH. Thereby we can reduce the oxidation and also hydroxides in that water. And also we can eliminate this uranium by the other process called reverse osmosis also, and stripping process also. And some more in situ chemical stabilizations that is effective for the elimination of this uranium, that is the redox technologies. Okay, in this technology they're going to use a chemical called the acetate solution they use. Okay, this acetate solution, it will going to reduce the concentration level of uranium in the groundwater. And also they go with the cooperated iron oxy hydroxide work also. And also phosphate precipitation technology. Okay, they are going to reduce the stability of uranium in the groundwater, and the flushing technology also. And some more pilot studies you can see here, bioremediation of uranium contaminated groundwater. Okay, here they're going to basically, I just point out one more thing here. Even this uranium, it will also cause by the biological action inside the earth also. Okay, there is a bacteria. That bacteria, it is nothing but geobacter. We call it as a geobacter. This is the bacteria. It is have a ability to oxidize metals and organic chemicals and even iron, fluoride, and the uranium and some other chemicals also. This bacteria, it can easily oxidize the uranium also, and it will turn that uranium into uranyl, and that uranyl, it will easily mixing with that water. Okay, so that is the bacteria. And also we can also eliminate this uranium by groundwater by natural zeolite process also. And also the we can also eliminate this uranium by permeable reactive barriers also. Okay, like a bone chair phosphates, by using ferric ion across the flow of uranium contaminated water, we can lower the input of uranium concentration in the groundwater. So this is about the topic. Thank you. If you have any doubts, you can ask.
Dear participants, any queries or clarifications? You can ask, sir.
Hope everyone are clear with this. Thank you. Thank you,
Thank you.
everyone.
Thank you, sir. Thank you, sir, for sharing your experience and knowledge with us. Uh, and last but not least, we have a Professor Anil Kumar MS, Assistant Professor Civil Engineering Department, to give a vote of thanks. Over to you, sir.
Thank you, sir. Good evening to all. It gives me an immense pleasure to deliver the vote of thanks for this event. I would like to thank IIC sir, SVCE for giving an opportunity to conduct webinar on climate change and its impact and uranium occurrence in shallow aquifers in Karnataka. I would like to thank our chairman sir Sri Muniappa sir and Sri Shishidhar Muniappa sir, Chief Executive Director, Sri Venkateshwara Group of Institution. I would like to thank our beloved principal Dr. Nageshwar Gupta sir, SVCE, Dr. Nirmala S. Gupta madam, IIC convener, professor and head, Department of CSC and Artificial Intelligence SVCE, Dr. Lata MS, professor and HOD, Department of Civil Engineering, and our today's session speakers S. Aravindan and Abhishek, assistant professors, Department of Civil Engineering SVCE. I would like to thank all the HODs from various department, staff members, and all the participants for making this function and event as a great success. Once again, I would thank one and all who are all present here. Thank you, sir. Over to you, sir.
So I would like to thank actually Lata ma'am, Professor and Head Department of Civil Engineering, and I would like to thank our Chairman Sir, CED Sir, and Principal Sir, whose constant support and guidelines to take this IIC cell to the greater heights to achieve the 5 stars in the whole country. So we are very happy that this initiative was being successfully planned and executed. So I would like to thank the entire team, Lata ma'am, and the entire speakers and the coordinators. And special thanks to all my dear students and peer members of SVC family. So thank you from IIC Cell as convener. Thank you.
Thank you, ma'am.
Over to Chandrasekhar sir.
Yes, ma'am. It's the end of the session, today's session. Now everyone may leave the session. Thank you, everyone.
Sorry to say this. There is a feedback link which is being posted in the chat box. Our organization people, I think, can see that. The rest of the people, please personally you share it, sir, based upon the registration. I would like to request everyone to give your valuable feedback. So I'm just sharing it in the chat box. The feedback link is shared in the chat box. So our organization people or MS team ID, whoever we are having, so we are all eligible and able to see that link. Otherwise also in Kaisala, I will push it to students as well as faculty members. Those who have attended today's event can give their valuable feedback by end of the day. The form will be kept open up to end of the day. So thank you one and all. Thank you very much.
Thank you, ma'am.
Thank you, madam.